Hello guys, welcome to our video of series called C# for beginners. So every program we've built this whole series has run entirely on its own, no internet, no external data, but real applications constantly talk to the outside world, fetching weather data, checking prices, posting a comment, logging in. Today we are learning how to make our C# programs actually talk to the internet using something called HttpClient. This is genuinely one of the biggest, most practical lessons in this series. By the end, your programs will be able to send and receive real data from real servers. And we're gonna need the first thing is HTTP client, and client equals new HTTP client. Okay, HTTP client is think of it as our program's phone, the thing we'll use to actually make calls out to servers. Okay, and important thing is here only while you are working in one file, create only one HTTP client and reuse it. Don't create a new one for every single request. Okay, and HTTP client is our tool for making any kind of web request. Everything else today builds on top of this one object. Let's make our very first real request, fetching data from an actual public API. To do that, we're gonna need HTTP response message and then maybe R1 equals await client dot get async and then HTTPS. I think it was, what was the name? It's JSON placeholder, something like that. JSON placeholder dot what was that? Let me check it. JSON placeholder. Yes, JSON placeholder dot typecode.com. Yes, and then users, and then maybe first one. Okay. Await client.getAsync and a URL. Remember, async and await from a few lessons back. Network calls are genuinely slow and predictable operations, so this is always async. GetAsync sends a GET request, the type of request used for simply retrieving data to that URL. This is particularly endpoint gives us back a single fake user with an ID of 1. So string response body equals r1 await r1 dot content dot get as no read as string async r1 no read as string async and then console dot writeline response body. Okay, await response dot content dot read as string async. Yes, the response itself does not directly hand us the text. We need to separately read its content as a string, and that's async too, since it might be still arriving. Okay, so let's see the output here. As you can see, it's the user with ID 1, name is Lena Graham, username is Brett, email, and other details of user. Yes, GetAsync is the starting point for fetching any data from the web, genuinely the most common HTTP request you'll make. So that response, or the variable R1 here, response, from a second ago, let's actually look at what it contains beyond just the content. Okay. Here we can see, let's just delete that, and console dot writeline r1 dot status code. Okay, the response dot status code that tells us how the request actually went, and okay means successfully. Let's see the output. As you can see, it's okay. Okay, that means successfully. And here's also one function which is console.writeline and r1 dot is success status code, and then true. Is success status code a genuinely convenient shortcut, true or false, namely a Boolean value for did this request succeeded or not, without needing to manually check the exact status code yourself. And then there is a headers console, console dot writeline r1 dot headers. Okay, let's see the headers. Lots of information here. Here's the extra metadata server sent back alongside the actual content like caching info or content tab or some kind of dates like this or something like the additional informations about the request, when it's made, how it's made, or something like that. Okay, HTTP response message is genuinely the whole package, status, headers, and content, everything the server sent back, not just the raw text. Okay, let's dig into that stats code a bit more, since it's genuinely important for knowing whether something actually worked or not. Here, we are making request to user 1. Let's make it 9999 or something like that, okay? And then this time request the user genuinely does not exist in this fake dataset because it only has users with IDs from 1 through 10. Okay, so that means the user with the ID 9999 does not exist. So that's why we need to check if r1 dot status code equal HTTP status codes, I think HTTP status code dot, okay, not found, not found, console dot writeline the user not found. Okay, else if r1 dot is success status console dot writeline the user was found, and else console dot writeline something went wrong. Okay, and we are checking specifically for HTTP status code dot not found. Remember the enums from the structs and enums lesson, right? Status codes are represented as an enum in C# language, giving us meaningful names instead of just raw numbers like 404 or 200 or 500 or something like that. So before running the program, let me show you the one of the common status codes for you. Okay, the first one is 200. That means that, as we saw before, it's okay status code. That means it succeeded and everything is good. Okay, and the second is 201. It's also okay, but that's for the actions that we are posting, not just getting data. Posting whenever using you are using the Instagram, for example, you kind of post story or post a new content. Yes, you are uploading some kind of file, or you are uploading some kind of form to database of the system that you are using. So that means you are creating something new. So it returns, if it's successful, 201 status code. That means created. Okay, and then bad request, like something bad, and 400 is bad request. That means the request itself was malformed. Okay, and then 401 not unauthorized, unauthorized. You need to authenticate. Okay, whenever you are not logged in, the programmer can strict some kind of actions to make sure the only logged in users can make this action. Okay, whenever you are not logged in and try to do this action, the error comes with 401, means you are not unauthorized. That means you need to sign up or log in. And then 404, that means not found. That means the information that you are looking for is not exist in database or in the website. And then 500, that means internal server error. Internal error. That means something broke on server side, okay? Words having a rough sense is 200s generally means success, 400s means you or the caller did something wrong, and 500s mean the server itself broke. This distinction genuinely helps when debugging why a request failed. And before moving the next topic, let me run the code to show the result. And user not found because the user with the ID 999 did not exist in that API that we are using. Okay. Checking stats codes properly rather than assuming every request succeeded is genuinely essential for building software that handles real-world network and predictability gracefully. Okay? Now imagine we are making several requests to the exact API, writing the full URL every single time gets repetitive and error prone. What I mean is here, for example, something like that. Okay? Notice we are repeating the base URL, HTTPS JSONPlaceholder typecode.com every single time. We can actually fix that. How? By creating API client. Just call it API client, and then API client dot base address. We're gonna make equals new URI HTTPS and JSON placeholder dot typecode.com and then this one. Okay. API client dot base address equals new URI and our base URL. This sets up a shared starting point for every request this specific client makes. And now we can have var r1 equals await API client dot get assigned maybe users 1 and var r2 equals await API client dot get assigned users maybe 5. Okay. Now our individual requests only need the relative path, just user1 or user5, and C# automatically combines it with that base address, giving us the same full URL as before, with a lot less repetition. Okay. Base address is genuinely a small convenience but a meaningful one. Set it once per API you are working with, and every request afterward stays shorter and less error prone. Okay, so far we've been only retrieving data GET requests, but what about sending data to server, like submitting a form or creating a new record, or as I said before, creating a new post? That's what post requests are for. Let me show you example. For example, var form data, and then maybe we're gonna have new dictionary, and string, and then title, my first post, and then body. This is the content. Remember dictionary from the collections lesson, a simple set of key value pairs representing the data we want to send. And then content var content equals new form URL encode content form data. That form URL encoded content form data, this package our dictionary into a specific format a server typically expect for form submission. Okay, so it kind of encodes the code that easy to send to a server or so wherever it wanna send. That's easy to kind of hold the information and give to another API or server and then decode it. Okay, first we need to encode it, and they know some kind of script they use to encode it, and then whenever we get the information in the place that we are sending the request or posting it, and then we decode it to get the real information. So, and then we're gonna do something like that: HTTP response message and response equals await API client dot post async, and then posts. Okay, and here content. Okay, await client.post assigning our URL and our packaged content. Same assigning pattern as get assigning, but post assigning specifically sends data along with the request rather than just asking for something back. JSON placeholder will actually respond with a fake created post complete with a new ID, even though nothing genuinely saved it on their servers. Okay, so let's see the output console dot writeLine response dot status code. Okay, as you can see, it's created, and we check the stats and it's created. That means post assigning is for sending data to a server, creating something new, submitting a form, as opposed to get assigning, which just retrieves existing data. Okay. Now, honestly, most modern APIs don't expect form data like we just sent. They expect JSON. Remember JSON serialization from the file IO lesson. And let me show you example. Maybe, as I said before, let's use the posts. Okay. First, we're gonna need some class for new post, maybe new post, and then we're gonna have public string title get set, and then public string body get set, and then public int user id get set. Okay, then one. Oops. Oh, and now let's create new post equal new post, title equals maybe my first post, and then body, this is the content. Okay, a simple class matching what JSON placeholder expects for a new post title and body, and a user ID and an instance of it, generally the same pattern we've used it since the class lesson. Okay, and then we're gonna need string JSON body equals JSON serializer dot serialize our post, uh, converting our object into JSON string, exact same method from the file IO lesson, especially previous lesson, and then we're gonna need string content, and JSON content new string content, and we're gonna give here JSON body, JSON posy, oh posy, not posy, it's actually body, man, body, and here JSON body, and also encoding dot UTF-8 and application JSON. Okay, and string content JSON body encoding UTF-8 and application JSON disrupts our JSON string properly, telling the server exactly what kind of data it's receiving. Okay, as I said before, we use some kind of encoding using some kind of schemas That's here we are using the encoding UTF-8. You can use another encodings also. That's the way converting our data that's much more flexible to send or to post to a server. Whenever working with kind of huge data, it makes it easy to send. Okay, and here we're gonna see the result. HTTP response message. HTTP response. Oh, why? HTTP response message. Okay, R1 equals maybe await API client dot post async and then posts and JSON content. Okay, and then let's see the output console.writeLine r1.status code. Okay, let's see the output here. As you can see, it's created. Post async again, this time sending our property format JSON content instead of form data. Serialize your object into JSON, wrap it in string content with the right content type, and then post it using post async. This is generally the standard pattern for sending structured data to modern APIs. Okay, and naturally, once the server sends data back, usually as JSON, we want to convert it into real data, usable C# object, not just a raw string. Yes? That's why we're gonna need kind of instance for that, and then we're gonna create maybe class JSON placeholder placeholder user. Okay, public string name get set public string email get set. Okay, that's enough. Class matching the shape of data we expect back. Generally, only the fields we actually care about, name and email. We don't need to match every single property that API returns. Okay, for now that's enough. And actually, we're gonna need something called, if you remember, JSON property name, and then name here, and then JSON property name here email. To make sure it whenever deserializing, it finds the no, attributes of our class very well to match them. Okay, and then here let's just delete these ones, all of them actually. Okay, so now let's make our request HTTP response message r1 equals await API client dot post async and posts. Oh, actually get async, man. Yes, get async. Yep, and then users one. Okay, and then string JSON equals await response r1 dot content dot read as string async. Making our request and reading the raw JSON text back exactly as before. And then JSON placeholder user equals JSON serializer dot and deserialize and JSON placeholder user and our JSON. Okay, and we same deserialize method from the file IO lesson, converting the raw JSON string directly into a real usable object. Okay, and then before that we need to check whether it's null or not. User not null. We're gonna show console.writeLine user.name and user.email. Okay, and let's see the output here now. As you can see, we are getting only the name and email of that user using our class JSONPlaceholder user, which has only two attributes, name and email here. And here the genuinely useful shortcut for just skipping the manual string step. We can do something like that. Let me show you. With maybe user2 JSON placeholder and user2 equals await get from JSON get from JSON assigning why it's not client OPS client API client dot get from JSON assigning. Yep, and then here we're gonna need JSON placeholder user, and then here our users maybe two. Okay, console.writeLine maybe user two dot what maybe email. Okay, yes, Shana Melissa.tv, and it's working. Real-time saver here is let me show what I did here is get from JSON async combines the get request and also deserialization into a single line, skipping the separate read as string async the step entirely. Okay, generally what you'll reach for most often in real code once you are comfortable with what's happening underneath. Okay, deserialize turns a raw JSON text into a real object you can actually work with, and get from JSON assign is a convenient one-line shortcut for most common get and deserialize pattern. Now, sometimes a server needs extra information alongside your request, like the API key, providing the who you are. That's what headers are for. Okay. So let me just delete all of them. Okay. And here we can do client API client dot default request headers dot add user agent my C sharp app. Okay, and client dot default request headers dot add and user agent and my C sharp app. This adds a header to every single request this client makes from now on, in this case identifying our app to server. Some real-world APIs genuinely require this, even if JSON placeholder itself does not. Okay, and here's a common way of adding an authentication token. We can do API client dot default request headers dot add, and here authorization and here bearer, and here be your token. Okay, I'm gonna just type token, but the real token would be very long. Generally, one of the most common headers you'll add authorization with a bearer token, proving to the server you are allowed to access whatever you are requesting. Most real APIs, like unlike JSON placeholder, will actually require something like this. Okay, and let me show you the one example setting a header on just one specific request instead. Okay, for that we can do something like that. Maybe HTTP response message, maybe request or request message. Yes, actually we need request message. HTTP request message and request equals new HTTP request message, and then HTTP method dot get get, and then here our HTTPS, our URL.com. Okay, typecode.com, and then users1. Okay, users.1, and request dot headers dot add accepts application JSON and HTTP response message HTTP response message HTTP response message R1 actually await our API client dot send async request. Okay, and if you only want a header on one specific request rather than every request this client ever makes, build an HTTP request message manually, add the header just to it, and then send it with send async instead. Okay, headers carry extra metadata alongside your request, authentication tokens especially, and content types. App identification genuinely essential once you are working with real secured APIs. Okay, let's properly combine what we know about status code with exception handling from several lessons back to build genuinely robust request code. Okay, we can do something like that. Try HTTP response message R1 equals await our API client dot get async maybe users one, and then response of R1 dot ensure success status code. This is genuinely convenient. If the status code indicates any kind of failure, this line throws an exception immediately right there instead of us needing to manually check its success status code every time. Okay, and then we're gonna here have string content equals await r1 dot content dot read as string async, right? And then we're gonna just print our content and then catch HTTP requests request exception and x console.writeLine request failed request failed x.message. Okay, and catching the HTTP request exception specifically. Remember multiple catch blocks from the exception handling lesson. These catch network related failures specifically, server down, DNS failure, ensure success status code, triggering all of it. Okay, and here's also one genuinely important addition. Here we can do something like that. Before that, let me just show the run this. As you can see, it's just getting the information without any problem. That means our catch block is not being triggered. So let me show you one other example with try catch blocks. Try using var and cancellation token, new cancellation token time span dot from seconds from why there's from seconds. Okay, from seconds 5 and then HTTP response message r1 equals await our API client dot get async and then users one and then CTS dot token. Okay, but why it's showing kind of error or something like that? What's the meaning here? Cancellation token type used in the using statement must implement ID disposable. Okay, use that. Using ID disposable. What's the problem here, man? Using var CTS and then new cancellation token. Oh, actually it's cancellation token source. Yes, cancellation token source. And then r1 dot ensure stats code. Okay, and then catch task cancel exception. Here we're gonna say console.writeLine the request timeout out, and we can catch other example HTTP request exception. HTTP request exception, and then console.writeLine request failed, and the reason x dot message. And this one's genuinely important for real applications. A cancellation token source giving our request a 5-second time limit. If the server takes longer than that to respond, it throws a task cancelled exception instead of hanging forever. Networks are genuinely unpredictable, and our program that can freeze indefinitely waiting on a slow server is a real problem in production software. Okay, ensure success stats code plus try catch gives you clean, reliable error handling for network calls, and a timeout genuinely protects your application from hanging forever on a server that never responds. Okay. Alright, last couple of request types, quick since they follow the same exact pattern as everything else today. And as you remember, we had the new posts class. Let's use that again. I think we're gonna need new post again. Let's create that public string title. Okay, title get and set, and then public string body get and set, then public int user id get set equal 1. Okay, and let's create new post, new new post, new post equals, let's make it some updated post equals new post, new post, new post, title equals updated of updated title. Okay, and then body equals updated some content, and then maybe you can update user ID also, user ID maybe 7. Okay, and then string updated JSON equals JSON serializer again, serializer dot serialize our updated post, and then string content equals updated content equals new string content, and then updated JSON, and also in encoding dot utf8, and then here application JSON. Okay, and then HTTP response message of HTTP response message put response equals await our client var client equals new HTTP client, okay, and client dot put async oh, put at JSON async, not put async itself, yes, put async, and HTTPS JSON placeholder JSON placeholder type code.com and posts one, okay, put async. Why it's yes, here our model also update content, okay, and then let's see the output console.writeLine put response.stats code, okay, let's see the output here. As unhandled exception, no such host known, JSON placeholder. HTTPS JSON placeholder. Oh yes, it's .type code. Yep, .typecode.com. Yep, clear. .type code. Yes, okay. Put async used specifically for updating an existing resource rather than creating a new one like post does, okay? Same pattern, serialize, wrap the string content and send this time targeted post ID 1 specifically to update it, okay? And here we can make some kind of delete action with HTTP response message R2 actually R2 and until await client dot delete async, and then let's just copy it for now, delete async, and then here come posts one, okay, post one, and console dot writeLine r2 dot stats code. Let's see output. Okay, that means delete async genuinely the simplest of all, just a URL, no content needs, specifically for removing a resource on the server, in this case, post number 1, okay? Get reads, post creates, put updates, delete removes. Together, these four cover the overwhelming majority of what real applications do when talking to API. It's like kind of crude. C for creating, R for reading, U for updating, and D for deleting, okay? And to close things out, remember Task.WhenAll from the Async programming lesson. Let's apply it here, fetching several users at once instead of one at a time, okay? That would be a really interesting example. Let me comment, no, actually delete this one, and then here make it base address, okay, okay, base address, and then okay, here up client dot base address equals new URI, okay, we're gonna have int user IDs equals array 1 2 3, okay, and list of task of JSON placeholder. We need JSON placeholder user actually, yes. Let's create that JSON placeholder user. We're gonna have public string name, and then public string email, get and set. And here JSON property name JSON property name here email. Okay, and now here JSON placeholder user, it can be nullable. Tasks equals new list task JSON placeholder, and this one. Okay, for each int id in user IDs tasks dot add client dot get from JSON assign, yes, and type JSON placeholder user, and then we're gonna JSON placeholder, and here we're gonna interpolate it, and we already have com, and this one also here users, and then this one is id. Okay, this one, right? And then outside our loop JSON placeholder user array can be users equal await task dot when all tasks. Okay, then for each var user in users, if user is not null console dot readline user dot name user dot email. Okay, the three user IDs, and instead of awaiting each get from JSON Async one at a time, we collect them all into a list of tasks when await task when all. Remember from the Async lesson, this runs all three requests concurrently rather than waiting for each one sequentially. Generally, this can make a real measurable speed difference once you are fetching several things from API. Okay, so let's see output here. As you can see, we are getting the three users: Laren Garham, Erwin Howell, and Clement Bosch. Okay, combining everything from today with Task.WhenAll from a few lessons back, this is genuinely how professional applications fetch multiple pieces of data efficiently rather than one slow request time. Okay, and so that's all for today's lesson. So your task for today's lesson would be writing an async method that fetches all 10 users from JSON placeholder concurrently using task.whenAll. Then use what you learned about link queue a while back to print out just the name of users whose email address ends with .biz. Okay, so today, genuinely a huge lesson. We covered HTTP client basics, making GET requests, understanding HTTP response message, checking status codes, using base address, making post requests with both from data and JSON, and deserializing JSON responses, setting headers, properly handling HTTP errors and timeouts, put and delete requests, and finished by combining it all with async operations running concurrently. This lesson genuinely ties together nearly everything from this entire series: the classes, JSON, async exception handling, link queue, all of it working together to let your programs talk to the real internet. This is honestly a huge milestone in this series. You can now build real connected applications. Congratulations making this far. See you on the next lessons. I think that's the last video, or I'm gonna make one real big project to end this series. See you there. Take care.